Hey everyone! Today we're going to crack a little secret that's hidden inside something you see all the time, the simple, totally common cylinder. You ever just stare at your coffee mug or grab a soda can and think, how much can this thing actually hold? Not what the label says, its real mathematical volume. Well, that's the exact question we're going to tackle today. So, how do we figure that out? Well, you don't need any fancy equipment. All you need is a simple, kind of elegant formula. Think of it like a secret code that unlocks the volume of any cylinder out there. And to crack this code, we only need to meet three key players. Yep, just three. Think of them as the essential ingredients in our recipe for volume. Once you know these guys, the rest is a piece of cake. Okay, our first player is R, which stands for radius. This is just the distance from the very center of the cylinder's circular bottom straight out to the edge. Simple as that. And hey, quick pro tip here. If it's easier to just measure the whole way across the circle, the full width, that's called the diameter. Just take that number, chop it in half, and boom, you've got your radius. Player number 2 is even more straightforward. H for height. And yeah, it's exactly what it sounds like. It's just how tall the cylinder is, from the flat bottom all the way up to the flat top. And our final player is a true celebrity in the math world, the constant we call pi. Pi is kind of the magic number that makes circles work. For what we're doing today, all you gotta remember is it's a special number, roughly 3.14. All right, now that we've met our three players, we can finally reveal the secret code. The volume of a cylinder is simply pi times the radius squared times the height. That is it. That's the entire formula, right there. So knowing the formula is great, but actually using it, well, that's where the power is. So let's break it down into a simple, totally foolproof 4-step method you can use on any cylinder, anywhere. Here it is, a super clear process. First, find your radius. Second, you square it, which just means you multiply that number by itself. Third, you multiply that result by pi to get the area of the circular base. Think of it like figuring out how big the flat bottom is. And finally, you multiply that area by the cylinder's height. You're basically just stacking those flat circles on top of each other till you reach the top. It just makes sense, right? Okay, enough with the theory. Let's put this into practice. It's time to finally solve that mystery we started with and figure out the exact volume of a can. Let's do the math. Okay, so imagine we've measured our can. We find out its radius, R, is 3 centimeters, and its height, RH, is 10 centimeters. Perfect. We now have everything we need to get started. So step 1 is already done for us. Our radius is 3 centimeters. Let's move right on to step 2. We need to square that radius. So we're just going to calculate 3 times 3, and that gives us 9. Now notice the unit here. It's centimeters squared. That's because we're not just measuring a line anymore. We're calculating a 2-dimensional area. Perfect. On to step 3. We take that 9 and multiply it by our magic number, pi. This calculation is what gives us the total surface area of that flat, circular bottom of our can. And if we run the numbers, that gives us about 28.27 square centimeters. That is the exact amount of space the base of our can takes up. We're getting really close. And here it is, the final step. This is where we turn our flat, 2D circle into a full 3D volume. We take our base area of 28.27 and multiply it by the height of our can, which, remember, is 10 centimeters. And there we have it, 282.7 cubic centimeters. Mystery solved. We now know the exact volume of our can, all in a few simple steps. Pretty cool, huh? But this was never just about one can. The real beauty of what we just did is that this knowledge, it applies to tons of things you see every single day. You've basically just unlocked a new superpower for understanding the world around you. And that really is the key takeaway here. This formula isn't just some boring problem from a textbook. It's a practical, powerful tool. It's like a new lens that lets you see and measure the physical world in a whole new way. Just think about it. With this one formula, you can figure out how much water is in a round swimming pool, how much grain can fit into a huge farm silo, the displacement of a piston in an engine, or even how much is left in a tube of toothpaste. The applications are literally everywhere you look. So, we've cracked the code of the cylinder. We revealed its mathematical secrets. It really makes you wonder, doesn't it? Now that you can see the elegant math hiding inside something as simple as a can, what other everyday shapes are you curious about? What will you calculate next?